Welcome to General Structures 2 and Lateral Forces. Lesson 2, example number 1. And it says that long span steel joists spanning 72 feet between girders are used to support a roof. So as you can see, excuse me, I wrote down 72 foot for L, which is our length. And joists are spaced 6 feet on center. I said S is space equals 6 foot OC on center. Where are we? And then the dead load is 20 pounds per square foot, 20 psf. And the live load is 20 pounds per square foot. And the live load deflection is limited to, so let me say L or delta. Let me change. What do we got here? Alright, there you go. Delta max, we'll say, this is deflection max, equals L over 360. That's L. It's kind of... Let's try that again. L over 360. Alright, and we can go ahead and figure out what that is right now. So let's switch colors and move on here. And remember, when you're doing L over 360 or whatever, this L is in inches. So what you have to remember to do is do 72 foot times 12 inches per foot over 360. And that is going to be your maximum deflection. Let me get my calculator. That's going to be your maximum deflection. And sometimes you'll see that what's your maximum live load deflection, and they have different types of criteria that you just need to pay attention to what it is. In this case, it seems like our maximum total, well, let me think. No, it says the live load deflection is limited to L over 360. So in this case, it's not total, it's live load deflection. I should probably do that. Live load. Just so we remember. Alright, 72 times 12 divided by 360 is 2.4 inches. So that's how much we can deflect. And if you look at this, this is what's gonna, generally I'm assuming it looks like. So we have a, what I would call a beam. If these are joists, usually from what I've always understood, and people will use different terminology, but you have, I'm going to change colors just to make them look different. But since these are called joists, and you might have different ways of forming this in right there. Not forming it, but putting it in. And this is what this joist is called, or what the joist looks like, and it looks like it has these triangles, which makes it a truss, or similar to a truss type system. And these are called open web steel joists. But you'll see these, and they're cheap because they are standardized. They can mass produce these things, and that's why they're cheap. They don't have to, specifically design these for each one. They're similar to typical wood beams. Everything's the same. Everything, they just pop it out, and there you go. And for instance, they're simple supported right there, and they'll tell you how far you have to brace them, or like bridging. You have to put bridging on there, and they have these standard tables that you have, and I guess that is similar to if you get in the AISC book, or your steel book, let's call it, and excuse me, they will have these beams. Let me circle them. And if it's a simple span, you've gone over those equations, and those are pretty simple. You can get the I, and you can get your S, and you know that your bending is M over S, and that's what you get. And so you figure out, you pick a beam with your S to make sure that you get your FB, which maybe 0.6 FY. Let's assume equals FB. So let's say 50 KSI, and this may not be true, this 0.6, that's my assumption. You take, so let's say you have 50 KSI. I don't know why I'm going through this, I probably shouldn't be, I might be confusing. Times 0.6 equals, what, 30 KSI. And therefore, if you have a moment of, let's say, I don't know, I'm trying not to make it too high, let's say 15 foot kips, then you would have to go in and make sure, get an M over S that's less than this 30. And this is simplifying. Obviously, you have to multiply by 12 inches per foot to get 2 inches, and then you have to divide it by, let's say, 131. I think that's I forget which beam that is, but so 15, let's see if my assumption would work. Divided by 131, I'm just off my top of my head. Yes, it will by far work. Oh, and you find out that the actual bending is 1.37 KSI, and that is much, sorry, wrong way. And you'll find that it's much, much less than 1.37, and therefore you're good to go. So this is your allowable stress, and this is your actual. I guess I could write that real quick. So I kind of went off on a tangent right there, and I apologize, but that is, if you're looking at those beams, that's how you'll figure that out. So what that beam will end up looking like is you'll have a point load looking into where this is where a joist comes in. There's that I-beam. It's kind of hard to make a little I-beam here. And then you'll have, in this case we have 6 foot on center, so you'll have another point load, a point load, and a point load. For instance, all 6 foot on center, and then you'll have a column. So you'll have to figure out that. And that's pretty much your basic building system. And once again, it is more complicated than that, but that's the basic thought process. I was just trying to run you through that. All right. Oh well, I was going to try to erase that by doing Control-Z, but it's not working, so we'll just move on. All right, so in this case, we're not worried about those beams. We're just doing these open web steel joists, and we know that since they're supposed to be cheap, and actually designing these and doing them differently would be difficult. So we just want to figure out, hey, they have these standard lengths, and we know this standard length is 72 foot. 6 foot on center, what's going to work out? And the first thing we have to do is figure out what our load is. To go to those table, actually swing to the table, which it says use the some typical joist details are shown on page 32. And then, oh, I'm sorry, that's not what I was looking for. It says use the table on page 33. So let's go to page 33 and see what we need. And it looks like we need approximate weight in pounds per linear foot. All right. That's for the joist, so let's not worry about that. It looks like we need the clear span in feet. That sounds good. And then it has, under that clear span in feet, it looks like it has 2 numbers. And it's not really well marked, but the top one is the total load, which is, I'll call it total load, TL. Total load equals, in this case, dead load plus live load. So it's got total load over live load. So the top one's going to be total load, the bottom one's going to be live load. So you have to have less than less than each of those. So let's figure out what our loads are. We already know that it's the load is, dead load is 20 and the live load is 20 PSF, but in this case we're looking for linear feet, pounds per linear feet, PLF. And let me I'm going to go ahead and try to explain how we're getting this. So just in case somebody does not know. Alright, so there's a slab, let's say. It's going to be a crazy 3D drawing, and you're going to have, let's say a slab looks like this. Let's assume it's concrete. And then you have these joists that are running this way. There's one, let's say this is continuous, so let's do that. Let's switch colors real quick. And here's a joist, and it runs this way. And it hooks in. And it looks something like that. And I'm going to try to go a little bit faster because I'm going to run out of time if I try to go too slow on this. Alright, and then let's say there's another one at 6 foot center. Sorry. Good enough. I think you're getting what I'm throwing down, picking up what I'm throwing down. Alright, so and these are 6 foot on center. So as you can see, our distributed area is right here. It's in the middle. You can think of this as a one-way system where this is the distributed area of this girder, or this joist, sorry, and this over here is the distributed width of this joist. And if you're looking at it from above, let's say this is a longer system than that. You have a joist right there, you have a joist right here, joist right there, joist right there. I think you get what I'm saying. And similarly, your distributed area will be right there. And since the spacing is 6 foot, the area, so this is what? This is 6 foot. And this is also, this will be half that, it's 3 foot. And this will be half that, it's 3 foot. Alright, I think everybody knows that. I just wanted to point that out. That's where we're getting this. That's where how you're multiplying this PLF. You're getting this PLF from the PSF. You're multiplying it by the distributed area, and the distributed area is the spacing. It's a 6 foot on center. It's the same thing. It's actually half of that times 2, if you want to think of it that way. Alright, so moving right along, let's go ahead and figure this out. Let's go ahead. DL equals 20 PSF times 6 foot. That gives us what? 120. I don't need the calculator. 120 PLF. Live load is going to be the same. And then our total load is going to be 240 PLF. Alright, now we can go into the tables. We've got all the information we need. And it looks like in this table on page 33, and this is from the, what is that book again? It's called the Standard Specifications of Steel Joist Institute. And it's just a big book of tables, if you will. Probably a little bit more information, but mostly tables. Alright, and we want to use this information as our important information. This is our bottom. This is our top. Alright, so we want to go find minimum of 240. So let's start on the top. It looks like they are 36s. And that's the height of the joist. And we'll go over to 72, our clear span. And we want to go down. They've actually circled them in this. Makes it easy for you. And you go down 209. 240 is bigger than 209, but it is less than 267. And we go to there, and we also look at the live load, and it is less, so we'll circle that, and that means that's good. Now if you have it may be where it depends which one. I would use the 36 because compared to the 40 because it's lower, and usually you'll mess with height issues, so you'll want the thinner roof, but sometimes it won't matter, so you go whichever one is cheaper. In this case, the approximate weight is about the same, so you would assume that the 36 would be a slightly lighter. So I would go ahead and use the 36. That might be a poor assumption, but you can call your fabricator and see what each one costs, and then go ahead and use the one that is cheaper. So in this case, I would use a 36LH09. And you could also go ahead and look at your live load max flexion and calculate, and you'll find that that's correct. It fits that.